Bam. If everyone is hearing me clearly. Hi, Nisham. Okay, thank you so much. I want to welcome you to my lecture today. Today, we're going to continue from deck 5. We started this, 2 days ago on conditional probability and expectation. We're still going to continue working with this material because there's a lot in this material. I think as a kind of recap on what we've done, walk you to a joint probability distribution, and we can actually obtain the marginal distribution, from the joint. Okay, so this is a situation where, the X and Y are discrete in nature, and we can actually find the marginal. Okay, so I need you to also watch out for question like this in the midterm too, where you're actually going to be giving a a cross tabulation table like this, and you actually they want to find the marginal distribution of X. You can be asked to find but if you want to find the marginal distribution of X, it's gonna be like here now. If this guy is 1, 2, 3, and 1, 2, 3. So if I ask you to find what is the marginal distribution of X, where X equal to 2. Where X equal to 2, it means I'm actually asking about white. Okay, where X equal to white. And that marginal distribution, you're actually going to add up this guy, so which is going to be 1/3. What if in a situation where I ask you to find the marginal distribution of Y equal to 3? Okay, the Y equal to 3 is, I'm talking about graph, right? Okay, so it means I'm actually going to add up, which is going to be half. So take a look at that. So that's the way we find the, marginals when X and Y are discrete in nature. So I think I've walked you through this the other time, and I've also, show you f of x, you have to sum the f of x, y, okay, over the range of y. And to get f of y, you sum the f of x, y over the range of x. I think I've also told you that. And when you are working with the integration, when x and y are continuous, okay, instead of summing, you're actually going to be using integral sign. So I think I've worked, and I also remember I talked about the conditional function. You don't forget about conditional function, how we get conditional function. Okay, so for conditional function, I think I actually, if you want to find f of x given y, okay, it's basically going to be the joint, don't forget that, divided by f of y. Okay, now situation where x and y are discrete in nature, so this is going to be f of xy divided by f of xy, then summation over the range of x. So if it is continuous, that is basically going to be f of xy divided by integral f of xy dx. Okay, and you're going to use the range of x for that. So I think I've walked you through how you can get that, so take notes of that. But let me tell you what is new today. I'm basically want to show you what is new today. Give me 1 second. Now take a look at this now. If this is a marginal distribution of the f of s, that is an exponential distribution with parameter lambda. Okay, so this guy here is actually talking about x follow exponential distribution with parameter lambda. But here, this is the way the conditional is written for exponential. Okay, f of y given x. what am I going to do? You're basically going to see that here, okay, you are only plugging in, okay, instead of you are plugging in x for lambda. If you take a look at what we have here, you're plugging in. So the f of x, you're going to see here f of x equal to that, but the f of y given x is equal to this. Take a look at that. So they are not the same. Okay, that's a conditional way to write, the exponential distribution. Now, if for instance, if I have this guy now, and don't forget, when I have that guy, the f of x is this guy, right? You can find the mean. Of course, if you want to find the expected value of x for continuous random variable, you're basically going to have integral x f of x dx. Take a look at that. And that will end up in 1 over lambda. But what of in a situation where you want to find the conditional expectation? This guy here is unconditional. Okay, unconditional means, or we call that unconditional expectation. But this guy here is conditional. Okay, expectation. Okay, is conditional expectation. Now, the difference between them, I just wanted to see when you want to talk about unconditional expectation, you're basically going to use f of x. If you want to find the unconditional expectation of x, you're going to use f of x. But if you want to find conditional expectation of y given x, you're basically going to use a conditional function. That will be f of y given x. I wanted to take note of that. So the f of the f of y, because this is a y, you're gonna have a y here, you're gonna have the y. Okay, the f of y given us, okay, is actually this guy here that I showed you the other time. Okay, the takeaway is you have to know, this is part of the thing that you need to know. F of y given us is always going to be this guy here. Okay, that is f of y given x. I wanted to take note of that. And if you look at what the difference, what we get, if this is 1 over lambda, the expected value of y given x is going to be 1 over x. What do you take as happen? Okay, x as replaced lambda. Okay, look at that. X as replaced lambda instead of 1 over lambda. That's going to give you 1 over x. So take note of that. Okay, now I'm going to move. Now you want to find, take a look at this. You want to find the probability of s greater than a. Of course, if you want to find probability of s greater than a, you're actually going to use f of x. Okay, you're actually going to use a marginal distribution of x if you want to find probability about the probability that x is greater or equal or whatever probability you want to find. You have to make use of f of x. And s greater than a means you're actually going to use a start from here to infinity. All you just need to do, what is f of x? This is f of x for exponential. Okay, you integrate that. When you integrate that, you're going to put infinity. Okay, like if you take a look at this now, when I integrate that now, it's going to be lambda exponential raised to the power this divided by minus lambda a to infinity. Lambda cancel lambda. I'm going to have minus exponential raised to the power that infinity a. Now I'm going to plug in infinity into anywhere I see x. What am I going to have? So that is basically, give me 1 second. So I'm actually going to have, this is going to be negative exponential raised to the power minus lambda infinity minus lambda a. Okay, now negative infinity, anything exponential, anything raised by negative, exponential raised by negative infinity, this is going to be 0, and this is going to be a minus is going to be a plus. Then I'm basically going to have this, and that was why I got that guy. Take a look at that. Okay, I just want to now take a look at this guy here. Okay, it said find the probability of y given probability of y greater than a given x. Of course, here, anytime you say this, you're basically going to use a conditional function. This is different from this. This is a probability of x. This is talking about x. Then you're going to use f of x. But here it's telling you you're going to use a conditional function because they said the probability of y greater than a given x. Okay, you're going to use that guy. Okay, and everything is going to center on y. That's why you see f of y given that, then the y. Okay, and so this is going to be the range of y. And don't forget the f of y given s for exponential is this guy. See that? Then you integrate that and you use the range. And at the end of the day, if you compare this guy with this guy, what has happened again? X has replaced lambda. Okay, x has replaced lambda, just like what you have the other time. So take note of that. Okay, now I want to go to a complex function now. In case you don't understand what I want to do, please make sure you ask question. Now compare. If the PDF of x is this, look at that. That's a PDF of x, right? That's a marginal, right? Now, how do we find the expected value of x? Of course, this remains the formula. Expected value of x for a continuous random variable is basically going to be x, f of x dx. Don't forget. Then the range of integration here is going to be 0 to 1. That is the support of x. You see that? Or what I'm just going to do, this is x, this is x. What is f of x? The whole of this. Then I plug that in. Okay. And when I plug that in, okay, all what you just need here is to integrate. You want to integrate with respect to x. What I'm going to advise that you should do, if you want to integrate this guy, 4 of us write 1 over 2, okay, plus theta and integral 0 to 1. Okay, if you take a look at that guy, s squared, you can multiply that out, x theta, okay, then the x. You see the way I wrote that one? Then you can now integrate now. Okay, let me focus on what is what is inside the integral sign. Okay, if you want to focus on what is inside the integral sign, that would be x raised to the power 3 divided by 3 plus s squared theta divided by 2. Okay, from 0 to 1. Look at the way I integrated that. Okay, don't forget, here you still have 1 over half plus theta. That's a constant that you put outside. Okay, now all what you're just going to do, plug in where you have x, plug in 1. So here, 1 over 2 plus theta, okay, into when you plug in 1, that'll be 1 over 3, right? Plus, when you plug in 1, that will be theta over 2. By the time you plug in 0, the whole thing is going to minus 0. Now, this is what I have. Now, you just need to simplify that. Okay, when you simplify that, you actually going to end up, here. Okay, so that was how we got this. Okay, expected value of x will be equal to that. After integration, you simplify. Okay, now, but what if we're talking about the conditional, the PDF of y given s? If you take a look at this now, if this is the marginal, okay, if this is the marginal, if I want to write the conditional version of y given x, or what I'm just going to do, okay, I'm actually going to plug in. You actually going to see that where we have x, it turns to y, okay, and where you have theta, it actually turns to x. Look at that. I wanted to take a look at, focus on this guy and focus on this guy. Take a look at that once again. Okay, f of x is in terms of x and theta. Take a look at that. Theta here is more or less like a constant, right? Okay, if I want to find f of y given s, which is the conditional version of that, okay, I'm just going to plug in x. I'm going to plug in y for x and theta and x for theta. Okay, now here now, since I'm focusing on y because I want to figure out the probability density function of y given that x is observed. Then there's going to be the range. The range is going to be the range of y. Okay, now let's make an attempt. We can find a conditional expectation based on this conditional function. Okay, so if I want to find conditional expectation, take a look at that. So when I do the integration again with respect to y, anything other than y is going to be regarded as constant. This is what I got. Now compare those two. Compare this guy now with this guy. What has happened? X has replaced theta. Look at that. X has replaced theta, just like what I told you. If you look at theta here, X replaced that, okay? And Y replace X. Look at that. You see that? So take a look at the result that we have now. This is the conditional. This is unconditional mean, and this is a conditional mean. Look at the difference between the two. But what I'm trying to tell you now, the moment you know the marginal, okay, if you know the marginal, okay, you can actually figure out the conditional function of y given s. Okay, the only thing is just going to happen here, you're like s is going to replace theta and y is going to replace s. So take a look at that. Okay, see, based on this guy now, I have the f of x, right? If I want to find the probability of s greater than half, of course, finding probability of s greater than half, it means I'm basically going to use the marginal distribution of x, because I want to make inference about x. I'm actually going to use the marginal distribution of x. Now, this is the marginal distribution of x. I want to find the probability of s greater than half. Greater than half, it means I'm going to start from half, then to the maximum value. The maximum value given is 1. Take a look at that. That's why I have that range. Then f of x, and my f of x is this guy. Then I'm going to plug that in. Or what I'm just going to do is to integrate with respect to x. Then I'm going to, after integration, I'm going to plug in 1. Then I'm going to plug in half. Then I'm going to subtract and I'm going to end up in this. Take a look at that. Okay, but what if in a situation where I want to write the conditional version? The conditional version, I'm just going to replace x with theta with x, and I'm going to replace x with y. Look at that. Also, I got that. Then what if I want to perform the same, the probability of y now? Look at that. I want to do the probability of y now greater than half, given that x is observed. Okay. Now, I'm actually going to have this formula here. Like I said, f of y given s the y. Okay, and don't forget the conditional version, I can actually derive that from the unconditional. Okay, this is the same thing as unconditional function. Marginal is the same thing as unconditional, but this guy here is conditional. Okay, and what am I going to do? Of course, I'm just going to plug in x for theta and y for x. Okay, to be able to get the conditional. And that's exactly what I'm using here. At the end of the day, when I find the probability now, when I find the probability using the unconditional one, the unconditional function, which we call the marginal, look at what I got. When I find the probability using the conditional one, look at what I got. What has happened now? X has replaced theta. Look at that. X has replaced theta. You see that? Okay. Okay, is there anyone who need clarification on this before I move? Is there anyone in the clarification? Like I said, do not hide your feelings. I need you to ask me a question in case you don't get the information now. I need you to ask me a question. Is there anyone who need kind of clarification? Or is there anyone? I'm here now. Is there anyone want to ask question? I'm here now. Okay, is there anyone who actually need kind of clarification now? Is there anyone need clarification now? I'm actually gonna explain that. Like I said, I'm here for you. If there's anyone, basically gonna do that. It's my job. Okay, is there anyone who need clarification? If you are good with my explanation now, I need you to say yes, or you comment yes. If you're good with my explanation now, I need you to say yes, or you comment yes. I'm only saying one person that is saying that. I'm still waiting. Okay, thank you so much. I'm actually gonna move now. Okay, this is a parry, right? Okay, so I'm gonna move. Okay, now the next thing I want to talk about is what we call normalization. What do I mean by normalization? Okay, suppose H is a non-negative function. Does there exist a constant C such that F equal to CH? At times in a probability distribution, they can give you a probability function that have a constant in it. And how do we actually figure out the constant? Okay, so to figure out, like you see here, it's like a constant that we talk about. And the H here is a non-negative function, and the whole F is a probability distribution. Okay, so we actually want to figure out what C is going to be for F to be a valid PDF. Okay, I'm going to say that again. We are actually interested in finding what C is basically going to be, for F to be a valid PDF. And don't forget, H is a non-negative function. And we also expect F of S as well to be a non-negative function. Now, this is what according to the law, when I integrate F of S ds, it must be equal to 1. You know that, right? Okay, so that's a rule. Just like in a discrete random variable, the sum of f of s must be equal to 1. That's a rule. Okay, that's one of the probability axioms. Okay, now since our f of s equal to ch, okay, I can plug in f of s for ch, where I'm going to have integral c h of s ds. But because c is a constant, right, I can bring it out. That was why you see me bringing the constant out, right? Okay, when you bring the constant out, c, okay, when you solve for c now, solve for c, you're basically going to have that, right? If you divide both sides by integral of h of s ds, your c is basically going to be that. So this is your c now, right? This is your c, okay? That's your c, right? Okay, so which means if I want to find c, that's what I'm going to do, right? Okay, now if that is what I'm going to do, basically, when we're trying to tell the world now, your f of s can be written as this. So that implies your f of s equal to that. Your f of s, okay, is basically the h of x divided by integral of h of x dx. That is what your f of x is. Okay, so if your f of x is that, uh, for continuous, this is for continuous, and this is for discrete. If you see the denominator is the sum. The denominator is actually the sum. So we say h, a function h, is called an unnormalized PDF if it is non-negative and has a finite and not zero integral, in which case you have that. And of course, in unnormalized PMF, if it is non-negative and has a finite and not zero sum, in which case is that. So take a look at that. I've given you for for both discrete and continuous right now. And I'm actually gonna move. Okay, I'm gonna move now. Let me move. Okay, now what of this situation? I think I've just talked about univariate here. This is for univariate. The whole of that is for univariate. What do I mean by univariate? I'm focusing on X, just one unit. I'm focusing on unit of measurement, just X. Maybe X, weight. It could be weight I'm focusing on. But how does it normalization work when I focusing on two variables that are actually called bivariate? Okay, take a look at this. For discrete case, if I want to get the f of y given s, it's basically that, right? I think I've showed you that before. And for continuous, you have that, right? I've walked you through that before. Take note of that. Okay, in case you want to find the conditional. Okay, and what does that mean? Okay, laterally speaking, what we're trying to say, conditional equal joint divided by marginal. Okay, but if it is f of x given y, don't forget, you're still going to have a joint, except that you're going to have divided by f of y. Okay, if it is for f of y, okay, the way we do f of y for discrete is going to be sum f of xy. You're going to sum over the range of x. If you want to do that for continuous, f of xy dx, and you're going to use the range of x. Okay, so don't forget about that. I'm going to move now. I think so. So if that is, if conditional equal to joint divided by marginal, then if I want to find a joint, then the joint is going to be this multiplied by that. That's easy, right? Okay, I'm going to move. Okay, I think I've walked you through all of that. Now I want to move to a situation where we got more than two variables. Okay, you got more than two variables. Take a look at this guy. I want to find the f of u, v, w, x given y, z. 6 variables. Okay, where I'm seeking a function for 4 variables given 2 variables. Oh my God, joint. Joint means combine all of them. That's what we mean by joint. That's a joint. Combine all of that, all the variables. Divided by the function of the one that is depending on alone. You can see this 4 of this is depending on y and z. So here, that's why you have f of y, z. Take note of that. Okay? That's why you have f of y, z. Okay? Don't forget, the numerator is always going to be joint. The denominator is going to be the variable, the function of the variables that is conditioning on. That is a rule. That's exactly what I'm doing here. If I want to get this guy now, I can say, okay, this guy multiply by that guy. That's what you say here. That's so easy, right? Okay. So now I want to go into I want to go into some example now. Okay, you have f of x and y. They ask you to get marginal. Of course, what are you using here, right? You know, f of x will be equal to integral f of xy dy. Then you're going to use the range of y, 0 to 1. That's what you're doing here. Okay, and what happened here? There's a c, right? You want to find c, right? How will you find c? Okay, if you want to find c, okay, you're basically going to equate everything to 1. Okay, you're going to equate everything to 1. Like if I want to find c here now, okay, if I equate this guy to 1, okay, my c will be 1 divided by the whole of that. That will be my c. C will be 1 divided by the whole of 1 divided by x squared plus s plus 1 over 3. That is if I want to find c. Okay, if I want to find constant. But right now, I'm not finding the constant. I'm just finding f of x. This is my f of x. Okay, in terms of c. If I want to find the conditional, what do you think I'm actually going to do? How do I get this guy? Oh, how do I get that guy? Now I'm going to show you f of y given x is equal f of xy divided by f of x. Now, this is f of xy, right? And this is f of x, right? Okay, now it's going to be this divided by that. Look at that, to be able to get this. You see that? The c is going to cancel out. When you say, so what are you using? Using this guy here. Look at that. To arrive at that conditional. That's so easy, right? Look at that. When you know the formula, everything is going to be so easy. Okay? You given f of x, y. Okay? And you want to find the conditional f of y given s. You need to first get f of x. After getting f of x, then you use this guy here. He's going to end up, you're going to end up here. You're going to see that c is going to cancel out. Very easy, right? Okay. And you know what? What if you're given this? And they ask you to get f of x given y. You're still going to use the joint, except that you're going to use f of y. And which means you need to first come here, okay? Instead of you to do with respect to y, you're going to do with respect to x to be able to get this guy first, okay? Don't forget, that's so easy, right? Okay. Now, I think I've already explained that. Now, I want to go into more complicated model now, okay, where we're still on joint probability distribution. Somebody share with me now. Let me see. In the conditional of y given s, why do they get rid of c? That's a good question. This what is, why did we get rid of C? We do the ratio and the C cancel out. I'm going to show you now. Take a look at this. This is f of xy. It has C, right? F of x also have C. And to get this guy, look at what we use. F of y given s equal f of xy divided by f of x. Do you see that now? So it's like this divided by that, which is going to be C into x plus y all squared divided by C into s squared plus x plus 1 over 3. C cancel out. That was how you get it. Does the person understand now? The person that share with me? Do you understand how the C cancel out now? Okay, thank you too. That's my job. Okay, now I want to move to a complicated one. Okay, I want to talk about normal distribution, but this time, initially before, you remember when S follow normal distribution, we normally write it this way, and we're basically going to say f of x equal 1 over square root of 2 pi sigma squared exponential raised to power minus half x minus mu or squared this is sigma square around here. There's sigma squared. Okay. Now, when S follow normal and the conditional y given S also is normal distribution, how can we find the conditional distribution of S given y? Now, I wanted to take note of this. Okay, suppose the marginal distribution of X is this, right? It's a normal with mean mu variance sigma squared. And the conditional distribution of y given x is also normal with mean. The mean now is x. Okay, the mean is s. If you make it, you're going to say that s just replace mu, right? X replace mu, and sigma and toy square actually replace sigma squared. Now, you have f of x, and they said this is f of y given x. Now, you know what? You know the question now? How can you figure out f of x given y? That is what we want to find now. I'm going to say this again. You are given f of x, the marginal distribution of x, follow a certain probability distribution, and you are also given the conditional f of y given s. But what they want you to figure out now, they wanted to figure out the conditional distribution of x given y. This guy is not the same thing as this guy. They are not the same. F of y given x is different from f of x given y. Okay, if you want to do that, okay, we want to use the unnormalized joint PDF. I'm going to tell you which one is normalized, which one is unnormalized. Let me first write you normalize one. Normalize. For instance, for f of x, if x follow normal distribution, okay, it's going to be f of x equal 1 over square root of 2 pi sigma squared exponential raised to power minus r minus 1 over 2 sigma squared x minus mu all squared. This is a normalized one. That's a normalized one. Now, if I want to write it for this guy, the distribution of y or f of y given x, I'm basically going to write 1 over square root of 2 pi. Then I'm going to write tau squared. Okay. Then I'm going to write exponential raised to power minus r tau squared. Okay. Then I'm going to write y. Okay. Y minus x or squared. Okay, that's a normalized one. But when I say unnormalized one, if I want to talk about unnormalized, what I'm going to do, I'm not going to reckon with this guy here. I'm only going to reckon with the exponential. So which means I'm not going to reckon with this one. That's a constant sign. I'm not going to reckon with this guy. Okay, that guy is acting like a C. It's acting like a C, a constant. Okay, I only want to reckon with the exponential side. Okay, now what I'm going to do. Okay, I'm going to multiply. Okay, now take a look at it. This guy here is this guy. Oh, sorry, is this guy here. Okay, this guy. Okay, and this guy is this guy. You see what I've done? I'm only taking the unnormalized side of that, of the two distribution. Okay. I'm not going to, 1 over square root of 2 pi sigma squared, 1 over square root of 2 pi tau squared. They are the constant side. If I have the constant, if I have that constant with that, it becomes normalized. Without constant, it's become unnormalized. I'm only using the unnormalized now. That's why you see me. What am I doing? I'm multiplying them. Okay. This is for f of x. This is f of y given x. Okay. Now I'm multiplying this with this. Okay. You see that? Where am I? If I multiply this guy with this guy now, what do you think I'm going to get? Okay. What I'm going to get is going to be f of xy. Did you know that? That's what I'm going to get, right? Okay. Because this guy, because f of y given s is f of xy divided by f of x. And that is the reason why this multiplied by this will give this guy. And the moment I got this, do you know I will be able to get f of x given y? If I have a joint, I will be able to get f of x given y. What am I going to do? This is what I'm looking for, f of x given y. Of course, I can actually, if I want to get f of x given y, what am I going to do? It's just going to be the joint divided by f of y. So which means I need to figure out f of y. And when I figure out f of y, I'm going to use it to divide f of xy. And that will give me f of x given y. Okay, now take a look at this. I multiply this by that. Okay, now when I'm going to multiply that by that now, okay, there's something I'm going to show you. Okay, there's something I want to show you. I want to first work with this because I know multiplying this together give me a complex one, but I want to first say the word that this guy here, if I expand it, it's gonna lead us to quadratic. Okay, it's gonna lead us to quadratic function. Okay, now let me first work on this first. Okay, I'm gonna work on that first. Okay, because I want to be able to rewrite that. When you take a look at this exponential, okay, exponential on this. Okay, let me first focus on negative x minus mu all squared over 2. Okay, and leave out the sigma square first. Okay, which is what or even we can I can consider it together. Let me just consider what is on the exponent, just this guy. Okay, let me just consider that, expand that, because I want to be able to rewrite it as an origin of a quadratic equation. Quadratic expression is like that, right? So that I'll be able to find what is my A, what is my B, what is my C based on that. Now I'm going to show you now. Okay, now take a look at this guy. When you expand that, you're basically going to have that, right? And if you want to rewrite that, in that form, that's a quadratic formula origin, right? Now, whatever the coefficient of x squared is going to be A. And that is the reason why here, this guy, 1 minus 1 over 2 sigma squared is going to be A, because you're actually using this. What is going to be your B? Oh, coefficient of x. Mu over sigma squared is your B. And automatically, this guy is your C. Okay, your C now is negative mu squared divided by 2 sigma squared. Now, what can we see now? What we can see now, we've gotten our A to be that and B to be that. Now, if A equal to that and B equal to that, you can solve for sigma squared and mu in terms of A and B. Okay, when from here, you solve for mu and sigma squared, and that will give you this. What does that mean? Oh, sigma squared is equal to minus 1 over 2a. Mu equal to minus b over 2a. That's what we find now. Okay, after finding that, I'm going to show you what we're going to do next. Now, if you take a look at, we now want to consider the whole thing, multiplying this. When you multiply that using the law of indices, okay, using the law of indices, you're going to write a single exponential, and you're going to add this to this, right? Okay, that's exactly what we're doing now here. which I'm going to show you now. Okay, look at that. That's what we're doing now. You see that now? Okay, so combining that will give me this, right? Combining that will give me that, right? Okay, law of indices, right? Okay, then you expand. You expand this. Okay, when you expand this guy here, okay, that is what you're going to have. When you expand this guy, that is what you're going to have. Look at that. You expand that. And when you expand that now, okay, don't forget, we are still targeting AX squared plus BX plus C. Okay, the coefficient of X squared now is our A. That means that's a A, right? Okay, the coefficient of X, that's our B, right? And the whole of this is C. Okay, now if A equal to that and B equal to that, you can solve for mu and sigma now. So take a look at that. Okay, this is what happened. From here, you said, hey, equal minus 1 over 2 toy squared minus 1 over 2 sigma squared, and B equal y over toy squared, okay, plus mu over sigma squared. So what are you going to do here? Solve for mu and sigma squared. Okay, when you want to solve for mu and sigma squared, that means you want to get your mu in terms of A and B, and you want to get your sigma squared in terms of A and B. When you do that, okay, this is what you're going to have. Your mu equal to that now. Your sigma squared equal to that now. Take a look at that. What are you seeing now? Now, the conditioner, in fact, when you do the multiplication, that will automatically give you the f of x given y. So what we're trying to tell the world now is that the conditional distribution of x given y, okay, as mean equal to this and the variance equal to that. Okay, so you can see the conditional that's going to be the conditional f of x given y that we just talked about. You see that now? So that's exactly what we got. Now, is there anyone who need clarification with that? Don't forget, we find our A, B, and we, in terms of mu and sigma squared, and we now solve for mu and sigma squared in terms of A, B, and that actually lead us to that. So take a look at what we have now. Okay, so if that is taken now, that's so easy, right? Now, you now know the general formula. I think I've walked you through all of that. And if you have more variables, f of x, y, z is going to be all this. So just for formula sake, okay, that's for formula sake, we've done all that. Okay, I think I've walked you through all that. I'm going to quickly move. Okay, another thing I want to walk you through today is what we call iterated expectation. Do you know that when I find the expect where if x and y are continuous, you know, inside here, that's a conditional mean, right? Conditional mean, right? Do you know that if I find the expectation of a conditional mean, we give us unconditional mean? Okay, the expectation of a conditional mean will give us, you know, or the expectation of a conditional mean will give us unconditional mean. Let's get started. Okay, now I want to find the expected value of the whole of that. Okay, of course, I'm going to put that f of x dx, because you know the expected value of whatever. Okay, let's say the expected value of Kazim now will be, if Kazim is a continuous random variable, it's going to be, okay, Kazim, okay, and the probability distribution for Kazim, right? Okay, then D Kazim, you know that? Now I want to find the expectation of this guy now. Okay, this guy is going to be inside that. Okay, and if and what is the expected value of y given x? Okay, it is actually this guy. Don't forget, expected value of y given x is basically, I'm going to say y. I'm going to use f of y dx. Then this is the y. That's what you see inside here, right? And this f of x is the one here. Okay, now I'm having two integral now, right? Then write the whole thing that you have here. Okay, now when you write the whole thing that you have here, take a look at this guy. That is the same thing as f of x, y. You remember f of xy is f of y given x multiplied by f of x. You know that? And if this is what you have now, okay, so what are we actually talking about? Okay, what we are actually talking about, take a look at this guy. When you take an integral, one integral, f of x y dy, okay, when you do that, so what are you going to get? That means you want to get f of x. And when you take an integral here, like if you take this integral, okay, and ds, you take one integral and write f of xy dx. What is it going to give? F of y, right? Now, if you have f of y, what are you going to be left with? So you know you use this integral and you use that, you're going to be left with integral y, f of y, the y, and what does this one means? That is the expected value of y, which is this guy here. So that is how to show that the expectation of a conditional mean will lead you to unconditional mean. Okay, and if x and y are discrete, the integral sign will only, summation sign will replace integral sign. Okay, I just wanted to take note of that. So this is what we just proved now. Okay, now remember axioms for conditional expectation. Okay, these are axioms. Expected value of x plus y given z is basically going to be that. Okay, you remember that when we do the conditional one the other time, linearity of expectation, we normally have this, right? But now, if it is conditionally on z, then we're going to have that. That's so easy, right? And provided the expected value of x given z is greater or equal to 0. Now for the constant is going to come out. So just take note of that. Okay. I think I want to solve one more problem. Let me see. Okay. Let's talk. You know, the other time I walk you through what we call the best prediction, right? And when we are talking about the best prediction, it depends on the criteria you're using. Okay. If the criteria you're using could be mean square error, the criteria you're using could be absolute error. If the criteria you're using is mean square error, is expected mean square error, then the best prediction is going to be the mean. If the criteria you're using is absolute error, the best prediction is going to be median. Okay, now take a look at this. Suppose x and y are joint distribution, f of xy, where x lie between 0 and 1 and y. What is the best prediction of y when x has been observed? What is the best prediction of y? Now to answer this question, that depends on the criteria. Whether if you're using mean square error, then you're going to find the mean. If you're using the absolute mean, the absolute error, you're going to find the median. Okay, now so that was why I said when the expected square prediction error is the criterion, then I'm basically going to find the expectation of y given s, which is the mean, conditional mean. Look at that. What is the best prediction of y when x has been observed? That's a conditional. It means I'm going to find the conditional mean. It's not going to be a conditional median. Okay, so but here they did not specify whether, so it means you're going to do it for the two criteria. Okay, if I want to do it, if I'm assuming expected square prediction error, I'm actually going to find the expected value of y given s. If we follow what we did before, that would be fantastic. Okay, now at the end of the day, you have your f of y given s to be that. Okay, so but in a situation where the criteria is median, okay, you actually, where the criteria is mean absolute error, you're going to find median. And how will you find median? You're going to refer to quantile. You need to first find the CDF. When you find the CDF, you find the quantile function. When you find the quantile function, wherever you see Q, you're going to plug in half in a quantile function. And that is the reason why here you can see I'm actually starting with the CDF. What is it? CDF of y given s. Okay, That going to be 0 to y. I'm going to find out this is CDF now. And after finding the CDF, you know what I'm going to do? I'm going to equate that to Q. And what is my Q? Q equal to half, because I'm dealing with the median. When this is like saying Q equal to half, you remember the other time the CDF and uppercase, I'm going to equate it to Q. But now, because I'm talking about median, Q equal to half. When Q equal to half, then I'm going to solve this quadratic equation. Don't forget, when I solve for, I'm looking for Y. At the end of the day, Y equal to that. Take a look at that. So, which means when this is the, you know, when the criteria, when the absolute error is being used, that I'm going to find the median. Median is going to be the best prediction. But when the mean square error is being used, I'm going to find the expectation of y given x. Okay, that's what I just. So here, this is just to plot the difference between the two, estimate that we got now for when the mean is used and when median is used. Is there anyone who need a clarification? This is where I'm gonna stop today. Is there anyone? Okay, your exam is gonna be posted on July, as described, as indicated in the syllabus. Like I said, you're gonna have 20 multiple choice question. You just need make sure you're actually going to spend 2 hours on the exam. Those who have sent the evidence of accommodation letter, they basically going to spend 3 hours. Almost today, I'm going to send instruction, just like what I did for exam 1. I'm going to send through announcement section. You're going to see exam instruction, what you can bring, what you can use in the exam. But let me tell you, let me confirm this to you. Your exam is going to be an open note, open book, open anything. You can open anything that will make you to succeed, except that you cannot search for anything online. You cannot seek assistance from your friend. You cannot provide assistance to your friend, okay? But to do whatever you know you can do that will make you succeed. It's an open book, it's an open note. You can use anything on the exam, except that you cannot search for anything online. I have a way to track that. If anyone search for anything online, and if anyone communicate, like, and the exam is going to be left open for 24 hours. You can start at any time you want within but only that it's going to be left open for 24 hours. The moment you click on start, okay, the moment you click on start, okay, your time is going to be running out. So make sure you actually plans wisely. Okay, make sure you plan wisely. Just take your time. Immediately you submit. Upon submission, oh my God, within 1 second, you basically going to see your result out of 100. Each question is 5 points. And 5 times 20, that would be 100, right? Okay. So make sure you take your time. Take your time. Okay. And believe you're actually going to succeed. I don't need your work. In this exam, you don't need to upload, nothing to upload. Okay. You just need to, work it, pick your answer. Or what I want to say is just the answer you pick. Okay, I'm not interested in you uploading any material or anything that maybe your workbook or worksheet. I don't need that. Okay, I'm going to say that again. I don't need that. I only need your response. And let me also tell you this: the exam is randomized. You can, if you communicate with your friend on the exam, that's not good. And even if you communicate, okay, the numbers are not the same. Okay, the numbers are not the same. So all what you just need to do is just focus on what we've done, particularly homework 2 solution, homework 3, okay, homework 4. Okay, if most of them is just going to revolve around, you have f of x, y, f of x, y is joint, could be discrete, could be continuous. Okay, figure out what is f of x, what is f of y, or what is f of x given y, or what is f of y given s, or what is the expected value of x, or what is the expected value of y, or what is the expected value of s given y, or what is the expected value of y given s, or you are given a linear combination. Okay, and they say, what is the expected value if y equal to x plus something? What is the expected value of y? Or what is the variance of y? Stuff like that. And I surely believe you're actually going to succeed. I'm very sure of that. You're going to succeed. Before I go today, is there anyone who want to ask a question? Okay, in the absence of question today, I'm going to say, make sure you stay safe and have a lovely day. Bye for now, everyone. Thank you too. Thank you, everyone.